Password hashes, a real important issue in the world of security. So if you have a password, in very early versions like MS-DOS of computer operating systems, they would just store that directly on the computer. And then if somebody hacked in and stole it, they'd have everybody's password, so that was considered bad. So instead they store a hash of the password, which it looks like this, just a bunch of random characters. And so the way they did that is they used a hash function called MD4. And so the only way to, MD4 is so old that the Python 3 library no longer supports it, so you have to add it in. So I have to execute this command to download it from a server, in one of my servers, download the MD4 Python code. And since this is a Google Colab environment, I can't execute a curl command because that's not Python. It's command line bash. So the way you do it is you put an exclamation point in front of it when you're in this environment. Then you can download the program and put it in the local folder space called md4.py. This is just somebody's code that does this, and you can look at the files here and you can see I do now have a file called md4.py among my local files. So now I can import it from that local file, have md4, and now I can calculate the md4 in hashed version of the string password. And there it is, 8A9, and that's the right answer. 8A9 is the correct start of the correct password hash for Windows operating system for passwords. Now, the Windows algorithm, however, this is a correct MD4, but it's not a correct Windows hash because Windows uses 16-bit Unicode, a very early version of an international operating system. So I need to encode it with 16 bits per character instead of 8 bits per character. So the H function has to change to this. So I'll put it in here. There. And now I get 8846, which is the right hash. This is the actual Windows hash for a password of password. So your first task is to make a hash dictionary for all 2-digit passwords that are numerical. And all right. And then you can hack Windows hashes. So you have a whole series of 3 users, Ming, Mohammed, and Sam, and you have to express it like this, and you're only going to be 100 possible passwords with the digits at the end, and you're going to crack these hashword hashes. And these are the actual real hashword hashes from Windows 7 machine. The way it works is the username is here, there's some empty fields here. This is an old thing called the landman hashes that is no longer used, so it always has this same constant just to be a placeholder, and the actual MD4 based hash is here. So that's the right hash value, and you have to calculate all those 100 password hashes and find out which one matches this, and then you'll have these passwords. And then there are more here you can do here where you actually use MD5 with several rounds, where you hash and then you hash the hash and hash the hash, which is called stretching. It's a modern procedure to make password hashing more secure. And there's another one here where you have many rounds of MD5 followed by many rounds of SHA-1. And you'll have to try a lot of them to get there. And then here's Linux password hashes. Linux password hashes are done with the crypt function. And here's Linux password hashes that are using the crypt function. You can see this is what Linux password hashes look like. You have a username, then you have $6, then you have a block of 16 characters before the next dollars. That's the salt, which is added to the password before you hash it to make it random. And then all the rest of this is the hash, and the hash is, I think in Linux, it's 5,000 rounds of SHA-512. So it's pretty crazy. But this is still NTLM hash. I don't think that's true. It says Linux hashes. Yeah. Yeah, that shouldn't say NTLM hashes. It's the Linux hash. That's the rightmost part of each line after the last colon. All right. And then there's even another bunch of hashes here, thanks to a student of mine that was good and pushy, is LastPass. LastPass actually uses 100,000 iterations of SHA-256. So here's hashes formed in that technique. So there's a bunch of hashes, and you have to make loops to try a lot of hashes to find these things. And a lot of extra credit available there, and they do get kind of difficult towards the end. So that's what I wanted to show you. I'm going to stop this recording.